What is the strangest thing humans have ever found on the moon? It's not aliens, and it's not a base, but something that shouldn't exist at all. With the unveiling of our crude lunar landers, this discovery has become critically important. It has been more than half a century since the last time Apollo astronauts set foot on the moon. No human footprints have touched that surface since. But dozens of probes have been sent there. Some landed successfully, some orbited, and some were even intentionally crashed into the moon to see what would happen. Overall, the moon is the most explored celestial body by humans. Yet, even after decades of study, it remains full of mysteries. From how it stores heat to how it conducts electricity, even the properties of its soil, we still know very little. The universe seems to work this way. The more we study it, the more questions we find. For example, before lunar soil was collected, there was great anticipation. But after samples were brought back, unexpected chemical traces kept appearing, things that shouldn't exist, leaving scientists puzzled for decades. You might think a scientific discovery immediately changes everything, but real scientific progress is slow. Sometimes everyone notices something, yet no one believes it. This story begins in 1976. The Soviet Union launched an unmanned probe called Luna 24. It was their final mission to collect lunar soil. At the time, nobody paid much attention to it. It wasn't the first mission, and it wasn't large. But in reality, it quietly did something significant. It drilled about 2 meters below the lunar surface and brought back a small core sample. The sample weighed only 170 grams, about the size of a baseball. Not much. But inside this narrow tube of dust, something strange appeared. A trace of water. About 0.1% of the sample contained water, and the deeper scientists studied it, the more water they seemed to find. This should have been a big deal, but instead, scientists assumed the water came from Earth contamination. Maybe from the lander, maybe from Earth-based equipment. After all, textbooks clearly stated the moon is dry, no water exists there. And this wasn't the first time. Similar signals had been found in Apollo samples, but they were also dismissed as contamination. So these clues, which should have caused a sensation, were buried in reports for decades, forgotten. Not until the turn of the century did scientists begin to reconsider, had we missed something important? But when we were finally ready to look again, the moon had prepared even more puzzles for us. If you stood at the edge of certain craters near the lunar poles, you would see something unnatural, not because something is there, but because nothing is there, not even light. These regions have been in permanent darkness for billions of years. They are called permanently shadowed regions. Why does this happen? Because the moon's tilt is only about 1.5 degrees. Sunlight barely grazes the poles, and deep craters block it completely. These areas have likely never seen sunlight in the entire history of the solar system. They are extremely cold. Temperatures can drop below -240 degrees Celsius, even colder than Pluto. In the 1990s, scientists proposed an idea. If comets or asteroids brought water to the moon, could it have drifted into these craters and frozen there forever? This idea became extremely popular because it meant the moon might not just be a dead rock, it could be a resource reservoir, a future refueling station. Watching from Earth was no longer enough. We had to get closer. But the problem was, the most promising places were also the hardest to reach. The terrain is rough. There's no sunlight, and solar panels are useless there. But the temptation was too great. What if there really was ice? So mission after mission was launched, with one goal: find solid proof. Scientists suspected ice was there. So what's the next step? Send a scout. But landing directly was too risky, so the first missions just orbited and observed. In 1994, NASA launched Clementine. It wasn't designed to find water. Its main job was mapping the moon. It confirmed that large, permanently shadowed craters exist near the South Pole,
but it didn't carry the right instruments to confirm the presence of ice. Then, in 1998, NASA launched Lunar Prospector. This time, the mission was focused on finding water. It used a special instrument to scan the moon and detected strong hydrogen signals at the poles, especially in shadowed regions. Scientists were thrilled. Estimates suggested tens of millions, even hundreds of millions of ice. This wasn't just a puddle, it could change everything. But there was a problem. Detecting hydrogen doesn't necessarily mean detecting water. It could be part of minerals or trapped in other compounds. The instruments couldn't distinguish. They could only say there is hydrogen, not whether it's ice. So what is it really? Even if it is water, orbiters can't directly see it. So once again, scientists were stuck. There was data, there were clues, but no final confirmation. It was as if the moon was saying, I have a treasure, but I won't let you see it. So scientists came up with a bold idea. If we can't see it from above, then let's smash into it. Yes, crash into the moon. The logic was simple. If ice is hidden at the bottom of craters, then hit it hard enough to blast material into sunlight and observe the debris. Brutal, but effective. The first attempt came in 1999, when Lunar Prospector was deliberately crashed into a crater near the South Pole. But unfortunately, it failed. No water was detected. Some said the angle was wrong. Others said the impact wasn't strong enough. 10 years later, in 2009, NASA's LCROSS mission changed everything. This time, they did something clever. They used the rocket's upper stage as a projectile, smashing it into a crater called Cabeus. Then, minutes later, the LCROSS spacecraft itself flew through the debris plume to analyze it. This time, it worked. Instruments detected water vapor in the plume. This wasn't a hint, it was measurable, real water. Not just water, methane, ammonia, and other compounds were found too. For the first time in history, humans had directly confirmed water on the moon. Headlines around the world celebrated it. Scientists opened champagne. It felt like a decades-long mystery had finally been solved. But very quickly, new questions appeared. How much water is there really? Is it solid ice or mixed into the soil like slush? And most importantly, is it easy to extract? LCROSS gave us answers, but it couldn't tell us more. We only knew that water exists, at least in that location. For a long time, the idea was simple. If there is water on the moon, it must be hidden in the coldest, darkest places. These areas act like natural freezers, preserving ice for billions of years. The logic seemed perfect, but the moon wasn't done surprising us. Orbital spacecraft began detecting faint signals of water molecules outside those dark craters, on sunlit parts of the lunar surface. This confused everyone. Finding water where sunlight hits. Daytime temperatures there can exceed 100 degrees Celsius. Water should disappear instantly. But it got even stranger. Scientists noticed these signals weren't constant. They followed a daily rhythm. At noon, when the surface is hottest, the signals weakened. But during morning and evening, they became stronger again. It was as if the moon was breathing water. Not oceans, not lakes, but tiny amounts, appearing and disappearing in a repeating cycle. This led to a shocking possibility. Water on the moon might not just be ancient, it might still be active. Some scientists proposed that solar wind, streams of charged particles from the sun, could be interacting with lunar soil. These particles carry hydrogen. When they strike oxygen-rich minerals in the moon's surface, they could form hydroxyl or even water molecules. In other words, the moon might be slowly creating water every single day. Not enough to drink, not enough to see, but enough to completely change our understanding. The moon was no longer just a dead, dry world. It was dynamic, subtle, strange, and perhaps far more important than we ever imagined. Because if water exists in multiple forms, frozen in shadows, trapped in soil, and even forming under sunlight, then future missions won't just visit the moon. They might live there. Water means fuel. Water means oxygen. Water means life support. And suddenly, that impossible discovery from 1976 doesn't seem so small anymore. It was the first clue, hidden in 170 grams of dust, that the moon was never what we thought it was. And even now, after decades of exploration, we are still only scratching the surface. Because the strangest thing we found on the moon wasn't just water. It was the realization that we were wrong all along.
The signals weakened or disappeared entirely, but in the evening, as temperatures dropped, the signals returned. What does that mean? Is the moon sweating? Heating up during the day, releasing water, then reabsorbing it at night? This idea was shocking. The moon has no atmosphere, no air pressure, no wind, no weather. On Earth, water evaporates, condenses, forms clouds and rain, a full water cycle. But the moon is bare and exposed, so where is this cycle coming from? This became one of the moon's biggest mysteries. Where does this water come from? Scientists proposed a few possibilities. One idea, it comes from space. Tiny meteorites constantly strike the moon like cosmic dust. They may carry small amounts of water or release water locked inside lunar minerals upon impact. Another idea is even more fascinating. The water is created by the sun. The sun constantly emits charged hydrogen particles, what we call the solar wind. When these particles hit the lunar surface, they interact with oxygen in the soil, forming water molecules right there. Regardless of the source, this discovery changed everything. It meant we might not need to rely only on those extreme polar craters. Maybe the entire moon is lightly covered with a thin layer of water, if only we can learn how to collect it. Suddenly, the possibilities exploded. Potential sites for future lunar bases expanded dramatically. This exciting possibility led to a new generation of missions, and in 2023, India stepped forward to take on this ultimate mystery. The mission? Chandrayaan-3. Its target, the moon's south pole, where scientists believed frozen water might be most concentrated. For the first time in history, a lander successfully reached this region. The world watched closely, waiting for one thing: confirmation of ice. The rover, Pragyan, began its journey. Using lasers and X-ray instruments, it analyzed the lunar soil in detail. And the result? Iron, aluminum, silicon, everything, except hydrogen. And without hydrogen, there is no water. Scientists were stunned. Where was the water that maps and data had promised? Had we been wrong all along? Or was the water simply buried too deep, beyond the reach of the rover's shallow tools? Before anyone could answer, the long lunar night arrived. Temperatures plunged below -100 degrees Celsius. Chandrayaan-3 did not survive the cold. It fell into permanent silence. But it didn't leave empty-handed. Before shutting down, it made one crucial discovery, almost by accident. Using a thermoprobe, it measured the heat of the lunar soil. The surface was scorching, over 60 degrees Celsius, but just 8 centimeters below, the temperature dropped to around -10 degrees Celsius. That's an extreme difference. What does that mean? It means the top layer of lunar soil acts like a thick, insulating blanket. Heat from the surface barely penetrates below, and this changes everything. It explains why the rover found no water, because it was searching only at the surface. The ice could be hiding just a few centimeters deeper, safe, preserved, protected under this insulating layer. So maybe the moon isn't dry at all. Maybe our tools just weren't good enough. The real problem is not the absence of water, but our inability to reach it. If this is true, then the next mission doesn't need to go farther. It just needs to dig deeper.
For decades, the search for water on the moon was seen as scientific curiosity, a way to better understand the moon's history, its geology, and how water moves across the solar system. But that is no longer the main reason we care about it. Today, lunar water means something far more direct, a stepping stone for humanity to move beyond Earth and the foundation of future space bases. Because if we can find usable water on the moon, enough to extract, purify, and store, it unlocks everything else. First, it makes long-term missions possible. Water is heavy, and launching it from Earth is extremely expensive. Transporting water into space is almost like shipping gold. But if astronauts can obtain water locally, they can reduce the supplies they need to carry. That water can be used for drinking, cooking, cleaning, and cooling equipment without constant resupply from Earth. Second, water can be split into hydrogen and oxygen, the same combination used as fuel in modern rockets. If we can extract ice and convert it into propellant, the moon becomes more than a destination. It becomes a refueling station, a place where spacecraft can refuel before heading deeper into space, to Mars, asteroids, and beyond. This completely changes the equation. Right now, every mission must carry all its fuel from the start, but a lunar refueling base would reduce that burden dramatically. Launching from the moon is also easier. Its gravity is only 1/6 of Earth's. That means less energy, lower cost, and greater flexibility. Spacecraft launched from the moon would not need massive rockets, just enough thrust to escape. Third, local water changes how we build. It can support closed-loop life systems, recycling waste into usable resources. It can even help grow food. Some plants can grow in lunar soil under controlled conditions, but they still need water. If enough water is found, future habitats may no longer depend entirely on supplies from Earth. In short, lunar water could play a decisive role in humanity's future in space. But there is still a problem. We don't yet know how much usable water exists or how easy it will be to extract, because all of these possibilities, fuel, bases, deep space missions, depend on one thing: actually getting the water. And that brings us to the final question. Despite all the missions, all the data, and all the optimism, the truth is, we still don't have a clear answer. Every time we feel like we're close to understanding the moon, it gives us something new, a contradictory reading, a missing signal, an unexpected result. And this pattern keeps repeating. From orbit, we detect strong hydrogen signals, but when we land, there's no hydrogen in the soil. We've seen water vapor and impact plumes, but no frost, no ice sheets, no visible accumulation. Even in craters that have never seen sunlight, places cold enough to preserve ice for billions of years, high-resolution cameras still haven't captured anything that clearly looks like ice. Instead, what we get is ambiguity. Surface probes find nothing. Water signals vanish during the day. Rovers drive across areas that should be rich in ice and find only dust. Even advanced technologies like shadow imaging cameras that can see into the darkest regions have yet to reveal the bright, reflective ice scientists expected. And that leads to an uncomfortable question. What if we've been wrong about how the moon stores water? What if our models need to be rewritten? Or worse, what if the water is there, but spread too thin, buried too deep, or chemically locked into the soil, beyond our current ability to extract it? Of course, there's another possibility. Maybe our tools, as precise as they are, still aren't good enough. Our orbiters are like eyes in the sky. They can see wide areas, but they can't touch. Our landers and rovers are like fingertips. They can touch, but they can't dig deep. All our exploration feels like scratching an itch through a layer of cloth, always just out of reach. Even the data we collect feels like a riddle. It tells us there is hydrogen, but not whether it belongs to water or to minerals. It shows bright reflections, but doesn't tell us if it's ice or something else entirely. And yet, humans don't give up. In fact, the more mysterious it becomes, the stronger our curiosity grows. New missions are already being planned, more powerful landers are being built, and all eyes remain fixed on that same place,
where we believe a hidden treasure lies. The next mission may carry better instruments, deeper drills, smarter extraction systems, no longer just testing, but finally breaking through. And from beneath that insulating lunar soil, we may one day lift a handful of something extraordinary, cold, solid, the future. Of course, the moon may surprise us again, revealing even more mysteries. But if we do succeed, if we finally uncover and harness that hidden water, then a new era will begin. One even greater than the first moon landing. And Earth, the blue world beneath our feet, will no longer be the cradle of civilization, but the harbor from which we set sail for the stars.